Do some experimentation. Let's get some experiments going on here. Let's move this up a little bit. There we go. Get our light right. No, it looks nice and pretty. Okay. Well. Oh, oh shoot. There we go. All right, get that spinning. Sweet. If I got another, yeah, I got another flask here. Got another flask here. Get some fluid in here. Get 2 flasks going. What do you say? Put a little stir bar in there. Get that stir bar spinning. How you doing there, King Jacks? Good to see you. Welcome aboard. We're just trying to get things set up here for some experiments. Talking about science and life. I always like doing this start. Showing how everything gets started. How everything gets set up. It's kind of cool. Hello there, Kanika. How's it going? Welcome aboard. Let's add a few drops of sodium hydroxide over here on the left. Yeah, get some good color changes going on. Then we'll get some universal indicator in this flask over here on the right. Let's do that. Okay. I'm doing okay, Kanika. Doing okay. Okay. I'm going to turn this down just a bit over here. All right, let's inject it in. Here we go. Hello there, William. So you'll notice the universal indicator's green. Thanks there, Nobara. I appreciate that a lot. Thanks for hanging out today. So you can see the universal indicator's green up here at the top on the right as I add it. But as it goes into the water and disperses into the water, it gains a yellow color, which indicates a pH of 6, which is slightly acidic. Hello there, King. Hello there, Silly. It's universal indicator in some water, and the yellow color tells us that the water is slightly acidic, which is kind of odd because water, you know, everybody thinks water is neutral, which, I mean, it is if it's pure. The issue is that almost no water is pure because water gets exposed to carbon dioxide from the atmosphere, and when carbon dioxide dissolves into water, it makes the water slightly acidic. Another squirt over here just for the heck of it. Get our colors going. There we go. Got our colors ready. Let's make hello there, King. Let's make them both red. I'm going to do that by adding some hydrochloric acid. It's the same acid that's found in your stomach, except this stuff is like 100 to 1,000 times more concentrated. And you can see that red color grow in, and that makes sense. I do too, Nobara. Yeah, put a heart emoji in the chat if you love some science. Here we go. We can see that the color is red. That indicates pH 3 or acidic. Amir approves. Yeah, let's add a little bit more hydrochloric acid over here on the left. You'll notice it's like an orange color. Oh, that's base. What am I doing? What am I doing? Hello there, Hassan. We're going to add a little bit of hydrochloric acid over here on the left. Like 6 drops. King Jacks, love some science. Braden's loving some science. Kanika's loving some science. And we've got pH 3 right now. I'm going to zoom in on this particular flask. And I'm going to slowly add. We might be making it purple here every day. We might. Nobara's loving some science. Hassan and Amir as well. Okay, I'm going to add drops of sodium hydroxide. There's our first drop. Here's our second. Me too, Nobara. Here's our third drop of sodium hydroxide. Hello, Poems. Glad to have you aboard again. Here's another drop. Beautiful flow patterns, huh? It's just kind of interesting to watch, I think. Hello, Caleb. What's going on? Check those out, man. Really pretty. And of course, you can see as I add the drops. Hello, Edwina. As I add the drops, the color shifts to a more green or blue, indicating a higher pH. Gorgeous. Looks like we're about a pH 7 right now. We're getting there, Konica. Science is indeed beautiful. In my location right now, it's about 2:30. 2:30 in the afternoon. And there's your purple. Come on, Konica. Give me a purple heart in the chat. All right, now we're going to do the same thing over here. All right. Here we go. Let's add a drop of base. Oh, that's pretty. Thank you, Konica. I appreciate that. Brainless adding the purple heart. King Patrick with a couple red hearts. Here we go. Adding a few more drops. Nobara. King Jacks ask. Hello, Gigabean. King Jacks asks, is it possible to get a higher acidity than 3, or does it stop there? You can get something more acidic than a pH of 3. It's just that this indicator system that I'm using at pH 3 or lower, it remains red. So the color's not going to change any lower. On the higher end too, if it's violet, it could be pH 10 or higher. So Nobara wants it blue. We're going to give that a shot. I'm going to add a little bit of hydrochloric acid over here on the left. Let's see. Just add 1 drop. See if we can get that to blue. So Konica, that's correct. HCl at a pH of 0, excuse me, at a concentration, I should say, of 0.1 molar is going to have a pH of 1. Let's see if we get that to blue. Come on, man. I think we got it. Oh, that might be green. Yeah, blue's tough to get. So what I'm going to try to do, you'll notice I went a little too far. It's like an aqua color. This is like pH 8. So if you look right up here at the top, I'm going to try to add a fractional drop. I do that by just squeezing a tiny little drop so that it adheres to the side of the flask. You can see it right there. And I'm just going to tilt this so that little bit of base goes in, and see if that's enough to make it go blue. Thank you, Nobar. I appreciate that. Looks like it wasn't quite enough, so I'm going to try the same thing again, just adding a fractional drop. A little bit of it went in. Let's add all of it and see if we can get that blue color. We're moving into the aqua region. Of course, here in the middle, you can see the blue color. I think maybe one more might do the trick. Might have to go a few more. Oh, it's wanting to go blue. Look at that. It's like an aqua right now. It's like a blue aqua. We are so close. Another small drop here. That's right, Gigabean. It is named after the element technetium. I think we got your blue there, right? We got our violet and we got our blue. There we go. We got the blue. Jim Bros is eating some pizza. Let's start adding some hydrochloric acid. Here we go. 1, 2, 3, 4, 5 drops on the left. 1, 2, 3, 4, 5, 6, 7 drops on the right. Seeing some beautiful color differences there. Yeah, that's one all the way to red. I'm going to add a few more drops over here. 1, 2, 3, 4, 5 drops on the left. Science for the win. That's right, Brian. Boy, this is taking a lot of acid over here on the left. Add 1 more drop over here. Boop. 1 more over here. Boop. Okay. Now I'm going to cut off the speed on both of them. We're going to add some sodium hydroxide. Let's go like 3 drops. 1, 2, 3, maybe 4, maybe 5. Let's do the same over here. All right, let's see what happens. Let's see what happens. Got some interesting patterns going over here. Again, what we have here is some universal indicator, and that's going to display different colors at different pH values. Interestingly, over here, I see red and violet very close to each other in the same flask, and that tells us that part of the flask has pH 3 and part of the flask has pH 10. Now, because the pH scale goes on powers of 10 in terms of the concentration of acid, this is a pH of 10, this is a pH of 3, that difference is 7. But because pH goes by powers of 10, that's a difference of acidity of 10 times 10, 7 times. That's 10 million. So in that flask right there, we are seeing a difference in acidity of 10 million times in the same flask. I am Brian. I'm a, hey, Abigail. So yeah, that's a huge difference in acidity right there in the same flask. And you might say, well, why does it persist? Well, it's because chemical reactions take some time, right? And it's going to take some time for all of that material to homogenize. I'm adding some base over here on the left. If we wait long enough, we might see some interesting effects happen. Thanks, Nobara. I appreciate that. Oh, look at that. That's some beautiful patterns, like a mosaic there. Really nice. Thanks there, Brian. I think W means win, but, you know, I'm not up on all the slang, so that's nice. See those patterns, those flow patterns as the base makes the dyes in there turn to a violet color. I'm going to add 3 drops of acid up here at the top, too, just see what kind of effects we can get. There we go. You can see them cascading down. Thanks, King Jax. Thank you all for keeping me up to date on all the slang. Does look like a rainbow, doesn't it? I think I'm going to do this is an interesting enough effect that I think I'm going to do a video on this someday on the, sometimes we get like a pH rainbow or a pH gradient in these. I agree. I agree, Gigabean. Science is beautiful. Chemistry for the win. Look at that. Come on, man. That is just really pretty. I wanna just lower the camera just a bit. There's some gunk going on here that I just think is really cool. Look at that. It's just gorgeous. It's really nice. King Jax, we got one of those yesterday. Toroids for the win. You think that's toroid? I guess, yeah, toroidal behavior. Thanks, Jim Bros. I agree, Nobara. It is pretty. Take a photo, sell it for art. I don't know about that. Maybe. You can see we're getting a little pH gradient here. Over here on the right. Yeah, we got the same over here on the left too. It's just kind of weird. Hey, Dark Inception, good to see you. Yeah, I you know, over the holidays it got a little difficult to do streams. So what we're going to do now, I'm going to go ahead and turn the stir bar on over here, and we're going to see if there's more acid or base present. So let's just give this a stir. Here we go. And it looks like we've got a slight excess of acid because everything turned yellow. That's giving us a pH of 6, right? So it's slightly acidic. Little gradient over here on the left. If I had to get, I'm going to leave this. This just looks so pretty. I'm going to leave that. I hope you don't mind that. I'll add some acid over here. Well, let's see if we can get a double rainbow. One that's more static, right? This one over here is sort of a static rainbow. And over here on the left, I'm going to try to get a dynamic rainbow so that the material that you see is changing colors very quickly, but still see if we can get a flash of the rainbow. Here we go. All right, here we go. Let's go like 5 drops. 1, 2, 3, 4, 5. I think I caught maybe a flash of a rainbow. Let's get a little bit more. Yeah, I think maybe we got a little flash rainbow. I agree, Jim Bros. That this is a very consistent thing that we see as the colors sort of settle over time. If you've been on this live before, you have noticed that as I do this experiment, it does tend to be the case that red, kind of diffuses to the top and violet diffuses to the bottom. It almost always happens that way. Hello, Shimura. Welcome aboard. Doing some experiments here. We've got a static rainbow on the right, and I'm trying to make a kinetic rainbow on the left. PIV says maybe it's because it's touching air at the top. Could be. I don't know. I honestly do not know. Here we go. 1, 2, 3, 4, 5. Did we get the rainbow? We did. Little flash of the rainbow. Thanks there, VH. I appreciate that. Ananya, I think it's also density would be my guess. Brian is asking, why does the red tend to go to the top, whereas the violet tends to go to the bottom? My guess is that the material, the hydronium ion that tends to make the solution red, is going to be less dense than the hydroxide, which is going to tend to sink to the bottom, although I don't know. TMX, I usually don't do this all day. I usually do about an hour. That's it. You just happen to catch me on a weekend when I've done it more than once. So I was on live yesterday, and I decided to do another live today. Thank you there, Nobara. Okay. I'm going to turn this one off. So, Marcus, what's going on? Give me a second here. You see this red fluid over here on the left. I'm going to go ahead and add some drops of base. And we'll check out what happens. Okay, what's going on in these flasks? To both flasks, I have added some, me too, Cosmic. I've added some universal indicator, which is also known as rainbow indicator. It's just a mixture of 4 different dyes. And what's interesting about those dyes is they display different colors at different pH values, or how acidic or basic something is. Here's the colors that universal indicator is going to display at the different pH values. If it's neutral, like pure water, it's going to display a green color. The more acidic it gets, the more red it gets, and the pH drops. The more basic it gets, the more violet it gets, and the pH increases. And you can see here what we've got going on in our systems. I did know that, Poems. Yep, great man. So if you look, I'm going to go ahead and add a bit more base over here. You'll see as I add base to this system over here on the left, you're going to see more violet colors grow in. Over here on the right, we got the whole rainbow, right? We got violet. Let's go with the top. Red. There's a little bit of orange and yellow over here. Here's green. Hey, come on, VH. Appreciate that. VH just sent me a monetary gift. Thank you. I really appreciate that. What is SUS 304? I always see it on metal. I apologize, Gigabean. I don't understand the question. VH, thank you very much for the gift. You guys, you don't got to give me money. Seriously, I really appreciate it, but that's not something that you need to do. All right? We're just hanging out together, folks. What you can do for me is you can support my channel by, sharing my videos and generating some support that way, and, subscribing and those types of things. So Anya asks, how's the color getting changed? So there are a mixture of dyes in here. The mixture of dyes in here that change color depending upon the acidity or basicity of the mixture, which is just how acidic it is. So up here at the top, there's a lot of protons around, and there happens to be a molecule in here that when there's a lot of protons around, we're gonna represent those protons by this silver washer, and the molecule by my gloved blue hand. And when this molecule sees those protons, it grabs onto them like this. And when it grabs onto them, the molecule takes on a circular structure, a ring-shaped structure. And when it has that structure, it has a certain color. That particular dye happens to be colorless, the one that I'm thinking about. Now, as you go down, the amount of protons goes away, and you have some bases present, which actually pulls away those protons from the molecule. And when those bases remove those protons, the molecule goes boop like that. It pops open. The ring pops open. And with that popping open of a ring, the color of the molecule changes. It goes from colorless in acid to colored in base. And the color that particular molecule I have in mind, it goes to a red color. And the red at that high pH mixes with some other molecules that look blue, and that gives you your violet color. So yeah, that's what's going on. So VH has a question about H2O and D2O. Are they the same thing? Chemically, they act very similarly. I'm going to go ahead and turn this one on while I answer this question. And we're going to see if there's more acid or base present. If they're in equal amounts, it'll be green. Yeah, Mr. Happy, we did indeed have a pH gradient on the solution on the right. And sure enough, it turned green, which meant the acid and base were fairly equal. So, is D2O the same as H2O? VH, you can look through some of my short videos that I have in which I do some experiments with D2O, or deuterium oxide, which is also known as heavy water. And in that case, the hydrogen atoms in water, in heavy water, are twice as heavy as the hydrogen atoms in regular water. So because of that, D2O is a little bit heavier. It's about 10% heavier than regular water, and because of that, it reacts a little more slowly. When's my birthday? I hate birthdays. Is it all right if I just don't answer that question? Thank you there, Marcus. I'm adding base right now. Gigabean, do my students know if I'm a YouTuber? Some of them do. I usually don't mention it to them, but yes, some of them know. How long does the color stay till the time the hydronium ions are available? Anya, the colors, how long they stay depends on a number of factors. The primary one is how fast the solution's being stirred. As you can see here, both of the mixtures are being stirred right now. And as I add base to the one on the left, you can see that violet color grow in. And that violet colored base is going to react with the acid that's present. And you'll see the violet was neutralized. So this flask over here on this side is now neutral. What's going on, Dob? Thank you there, Poems. Over here on the right, I'm going to add some acid. We can watch that. So I'm going to try to neutralize the base. We're at pH 10, and I've added 2 drops, maybe 3 drops of acid. Oh, we got a little flash of the rainbow there. It's beautiful. Nobar, it's mixing because, here, if you look, I'm going to turn this off. I'm down here, I'm turning a knob, and you can see down at the bottom, there's a little magnetic stir bar. And inside this box, I like to think of it as magnetic fan blades. When I turn the knob on, the fan blades start to spin, and that causes that little magnet to spin. You got it, VH. What's going on, Dob? Hello, Jim Bros. So now I've turned this one back on. I'm going to go ahead and make both of these acidic by adding a bunch of hydrochloric acid. That's 10 drops on the left. That's like 3 or 4 drops on the right. Interesting. Yeah, in YouTube shorts, they sometimes use these things to mix chocolate milk. Just makes it look pretty, you know. For me, it leaves my hands free where I can do some experiments and, get things ready off screen. And, it does the mixing for me. Oh, Poems has a birthday on February 14th, which is Valentine's Day. We got the appropriate color going on for Valentine's Day on the screen right now. Hey, Stefan. Great to see you. Glad you're still subscribed. Hope you've been checking out the videos I've been putting out. Let's go ahead and, I think I'm going to stop the flask on the right. And now I'm going to, PIV, I can't heat one and not the other. Sorry about that. January 6th, Nobara just had a birthday. Awesome, Marcus. Glad to hear you're going to be taking some chemistry. I won't tell anyone, Nobara. 29th of February, leap day for DOB. Owen, come on, man. Owen just sent me a gift. I appreciate that, Owen. We're going to add a few drops over here on the right of base. We're going to try to get that pH gradient going. Hello, Austin. Hey, Owen, why don't you drop a heart emoji with the color you would like me to see try to develop over here on the left. Hello, Patriot. Jim Bros, I agree, man. We keep it around 100, somewhere between 100 and 300. We're in good shape. So it wasn't once green. What's the significance of the experiment? What does this tell us about the properties of the chemicals and constituents used in the same? So Owen wants green. So what these colors tell you is the pH of the solution. So over here on the left, we can say that the pH is 3, which means it's acidic. Over here on the right, we've got a mixture of colors. I've got a whole lot of base and a little bit of acid. And probably if I mix this, I imagine the base will overcome the acid. I think I put a little too much base in. Let's see. The acid and base are going to react. And sure enough, there's an excess of base, which is why this remains at pH 10. I'm going to turn this off. I got to make some green over here for Owen. I'm going to add in some acid now. So we got 7 drops of acid over here on the right. I got to try to make this pH 7 over here. Can you just go black and come back to a red? I can't make the color black. Giga Bean, come on, man. You don't got to send me any money. I appreciate it, but really, you don't need to do that. Thank you very much. Appreciate that, Giga Bean. Marcus asks, why isn't there orange between the yellow and red? Well, if you look, Marcus, I think I may have generated some orange for you. Oh, I see. You mean on the chart. So this chart is just a guide. It's not, I tried to make this as best as I could with the printer colors that I have. Like pH 4, this is probably like a pH 4. You'll notice it's kind of orange in color, whereas this is over here is more red. So, yeah, I agree, Nobara. It's maybe a red-orange. So let's add another drop, just a tiny little drop. I'll do that by just barely touching this to the top here. Try to dry just a fractional drop. We're going to try to get this over here on the left to an orange color before I make it go green for Owen. Jim Bros, I appreciate that. I appreciate that a lot, but you don't need to worry about sending me any money. Y'all can just support my channel by sharing my videos and liking them and subscribing. I appreciate that. Patriot, I have worked with ferrofluid before. I got gloves on this side, Water Trails. I don't have to worry about over here. I mean, you're right. I could spill this on my hand. The solvent, Mr. Happy, I'm using is just plain old water. I'm going to add another drop over here. We got to get this to green. So I'm trying to increase. I appreciate the concern, Water, though, for my safety. Vertigo, this is not cobalt chloride. Thank you there, Nobara. This is universal indicator. And I think we may have got an orange color over here on the left. Let's add another drop. We're at like pH 4 or 5. We got to get this up to a pH of 7 for Owen. There's another drop. There you go, Marcus. We got the orange. Come on, there's another drop. Poems. I used to teach 8th grade back in the day, like a long time ago, back in the 1990s. What's up, Shivam? Add another drop. We got to try to get this going here. Look at the interesting flow patterns we got over here in the static flask. Pretty much what we're doing there, Water Trails. Pretty much, I've added universal indicator, which is an acid-base indicator to both of these flasks. The universal indicator tells us the pH, which is how acidic or basic something is. So over here on the right, you can see we got like a yellow-green color. So the pH is just a little bit above 6. And I keep adding base to try to get this to pH 7 is what I'm doing. Oh, yeah, I'm in my 50s. I'm closer to 60 than I am 50, Jim Bros. I'm an old man. I'm an old dude. I'm an old dude. I think we got your green. I think we got your green. I don't know what shade of green you want, but we've definitely got your green. You know, I think everybody's smart, Patriot. I think all of us have something to learn and all of us have something to teach. Waters, I love it. Owen wants some dark green. Yep. Like when I want to get my car fixed, I'm very glad there's people who know a heck of a lot more about cars than I do. Let's just put it that way. A lavender color. I'm wizened. Thanks, Patriot. All right, Owen, I got you. Well, Jim Bros, I hope you have a good day at school tomorrow. I'm adding more base over here on the left, making it a nice violet color. Gigabean, yeah, a lot of folks think I'm in my 40s. I took good care of myself. I exercise a lot. Beekman, what's going on, buddy? Got a former student in the chat. I am doing well. We're adding some acid over here on the left. Appreciate that, Poems. Mr. Happy, I'm going to need a little more information. What do you mean by EBT? Got to know what that, got to make sure I know what you're talking about there before I can answer. Can I explain sulfuric acid? Sure, what do you want to know about sulfuric acid? I can try to answer some questions, but I don't know if I'll be able to answer. 60 years young. What colors can I make? Oh, Rhychrome black tea, thanks. I don't have any of that with me, so no, I can't add any Rhychrome. Used to watch Beekman's World and Bill Nye. Nye became a rude git. I don't know what that means. I have no clue what that means. I'm not up on the slang, y'all. There we go. I'm adding acid over here on the left. Let's see. Ah, gotcha. I saw it there. Patriot. Just so you know. Why does a solution containing a mixture of different pH indicators, such as methyl orange and bromothymol blue, display multiple colors when the pH gradually changes, and how do they interact? Anya, glad you asked. Let me try to get that out. VH, I don't know what you mean by explain sulfuric acid. I do not know what that means. So here, Anya, let me answer your question. Forgive me, I got to get a little, let's get my diagram out here. Okay, so Anya wants to know how all these colors form with all the different dyes. Thanks, there, Patriot, but you don't got to worry about it. But I appreciate that a lot. I really do. If you want to donate, thank you, but it's not something you need to do. But thank you if you decide to. Okay, here we go. So here are the different indicators that are found in universal indicator. So universal indicator displays these colors. Sorry, it's getting a little out of focus. There we go. These colors at these different pH values. But universal indicator is really a combination of, I'm going to hide this, all four of these indicators. Now, the heart of universal indicator is thymol blue. Yes, Novara and Owen, pink is possible using just phenolphthalein alone. Now, back to these four indicators. Thymol blue is the heart of universal indicator. I can't do pink because I don't have any straight phenolphthalein. As you can see, thymol blue displays these colors at these different pH values. And you can see, okay, this is kind of like, getting close to the rainbow here. Cool, Patriot is a metallurgist. Now, by adding these different indicators, methyl red, bromothymol blue, and phenolphthalein to the mixture, what happens, say at pH 10, is you get 2 indicators that give a strong blue color, 1 indicator that gives a weak yellow color, and the blue overpowers the yellow, and this looks blue. And then the phenolphthalein adds a little bit of red to give you the violet color at pH 10. That's sort of the way it works, and you get the you get the idea. Jim Bros, thanks for recognizing that when it goes silent. I'm trying to read some long messages and figure out how to respond. Yeah, that's right. That's at water trails. Why didn't I just say that? It's just colors mixing. Pastel blue, says Nobara. I will try. So over here on the right, I'm going to add some acid to lower the pH because you want to get to blue. So we're at pH 10, but I got to get us down to, like a pH 9 or an 8. Ha, Grundle, I can't do that, man. I'm not making one of those. I suppose I could do that if I drank the universal indicator, because universal indicator, one of the dyes in there used to be the main ingredient in X-Lax. Oh, so VH means the strongest acid. So the strongest acid that I'm aware of is fluorantimonic acid, and the pH of that is something like -26 or -36, something like that. Mr. Happy, I'm going to go ahead and try to neutralize this solution over here on the left, because somebody asked to try to make blue over here on the right, so I'm not going to do both at the same time. So here we go over here on the left. What did you say? I want to neutralize it, so I'm going to add a little bit of sodium hydroxide to try to increase. No, sulfuric acid is not the strongest acid. Have a great day, Patriot. I'm going for it. There's your blue, Owen. Now I got to try to get it to pastel blue. I think I overshot. There's your green. Can I make hemoglobin red? Already is, Grundle. It already is. I don't have to worry about making it red. Madden, just a small drop up there at the top, trying to get you that pastel blue. It's really tough to get, man. I have such a hard trouble. Oh, are you saying hemoglobin red is the name of a color, Grundle? I'm no wizard. I'm just an old dude in the basement doing some chemistry experiments. Gotcha. Okay, I can make you some red there. I can do that. That's what we're going to do here in a second. Trying to get that pastel blue. Okay, over here on the left, I'm going to add a bunch of acid for Grundle, who wants it to look as red as hemoglobin. That's what we're going to do. There you go. I got a little pastel blue down at the bottom. I don't know if you saw it. So Gigabean is asking, is the pH only for what H plus and OH minus is? Thank you there, Grundle. Yeah, pH is a description of how much hydroxide OH minus and hydronium H3O plus is. Nabara, thanks for letting me know you're a girl. Please know that I call people bud a lot, male or female, and if that bothers you, I will do my best to refer to you as gal. Ashkan, yeah, that's the hemoglobin red I got for you. You got it, Water Trails. pH is indeed for H+. POH is for hydroxide ion concentration. However, of course, if you know pH, you can certainly find hydroxide concentration. So Anya says, why does the solution exhibit a smooth transition of colors across a range of pH values, and how does the specific color of each indicator correlate to the logarithmic scale of hydrogen ion concentration? Thanks, Nobar, for letting me know. Anya, I'm thinking about how to answer your question here. Leonard, that's pretty easy to do. Here we go. We're going to make them both red. Why does the solution exhibit a smooth transition of colors? So why it exhibits a smooth transition, and I'm not sure exactly, do you mean like this? I'm assuming you mean why does it show a smooth transition of colors like this? So you can answer that for each specific compound. So let's just go to phenolphthalein anyas. If there's a lot of H plus ions around, we're just looking at phenolphthalein. You're going to have a lot of molecules that have the proton attached and have the ring-shaped structure so that there are an enormous number of colorless molecules. Now, as you start to raise the pH, there's going to be a region where these molecules start to lose their protons and go pink. But you have to remember there are an enormous number of molecules in these flasks. You know, we're talking about, you know, like on the order of 10 to the power of 23, which is just a ginormous number. It's just gigantic. So you have to remember that of those molecules, when you get to the conditions where these start to be removed, not all of the molecules lose protons and go colored at the same time. There's a population of them. And so what happens is, as the base concentration increase, we'll say there's like 100 of them that are shaped like this. Maybe you get to the conditions where 1 out of the 99 lose the proton and pop open. And so it looks very faintly pink. And then as you continue to raise the pH, then you get to the point where 5 out of the 100, it's a little more pink. And then 10 out of the 100, where it's a little more pink. And then 50 out of the 100, which it's pretty much half of them are pink and half of them are colorless. And then as you continue to raise the pH, you finally get to the point where all of them, all 100 of them, are pink. So that's why there's a smooth transition of color, because that happens with every single compound that's in the flask. Owen, glad to have you back. Oh man, Ashkan spilled a 4-liter jug of sulfuric on the floor. Was it 18 molar? So Jim Bros is just asking if they could send me $500, what would I do with it? I would use it to buy stuff to make YouTube shorts with. Nice to hear, Gigabean. Gigabean's going to do some vids on their channel. So long, Owen. Yes, Dob, my name is definitely Tommy. I'm adding some bass over here on the left. We're going to see some interesting flow patterns. We are going to go ahead and cut the speed off over here on the right, and I'm going to add... Thanks there, Jim. That's fine, Nobara. Most people know me as Tom, to be honest with you. Most people call me Tom in, like, you know, in my personal life. Water Trails spilled some hydrochloric acid from a titration burette on the floor. Yeah, that's some beautiful rainbow action over there on the right. Can you actually remove the indicator from the sample solvent? Yeah, I think you could. You just have to boil off the water. Gotcha, Water Trails. Yeah, I usually don't worry about like 10th molar hydrochloric acid. Thank you there, Roblox, I think. Got a little bit of rainbow action going on here. Very beautiful. Yeah, chat, we made a rainbow. Love it, Nobara. All right, let's make a double rainbow. Cut this off and do it again. Yeah, it is cool. I agree, Jim Bros. I have to do a video on this. I think I need to do a video on the static rainbow, the pH gradient. It is gorgeous. It is absolutely gorgeous. Look at that swirl. Thank you, Poems. It is so beautiful. It's like a... I don't know how to describe it, man. It's very pretty. Very pretty. Okay. Yeah, I hope you all got to check out my recent YouTube short. I usually put them out on Saturdays. We'll be looking for them Saturday morning, and where I'm from is when they go out. This last one I did another experiment with gallon stand. I'm telling you what, you got to check it out. The doggone thing, it looks like, you know, I can take... Gallon stand's like it looks like mercury. So it looks like, yeah, it just looks like mercury. But but when I put it in a solution of iron ions, doggone it, it looks like the little blob of mercury comes alive. In some cases, it looks like a leech. In other cases, it looks like a snail. So, any chemistry jobs you recommend for anyone who has just finished college? Wow. I mean, there's a lot of stuff you can do. I'm sure there's a lot of lab jobs that you can pick up pretty much anywhere. Uh, I don't know where you live, so it's a little difficult to say, but like lab technician, you should be able to get that no problem at all. Um, you can always get paid to go to graduate school, um, which is kind of nice. So I don't know. It all depends on the area you're in. I'm gonna go ahead and turn this one on over here on the left. We're gonna see if there's more acid or base. That's a good question, Leonard. Would they keep their color if I froze them? I have no idea. That's interesting. You're still job hunting, only third year in college, and you're anxious. Yeah, sorry, Water Trails. Let me just tell you this. When I graduated from college in 1991, I put out 100 applications, just trying to get a job being a teacher. And of those 100 applications, I got 4 interviews. Now, of the interviews, I ended up getting 4 job offers of the 4 interviews I got. But nevertheless, there's a lot of work putting out all those applications. And I think that's just part of what's, I hate to tell you this, but part of what's got to happen when you're going for a job is, just getting serious about it and just putting out a lot of applications. So Ashkan says a couple years ago they were ampuling mercury, and a hot mercury ampule broke on them. So how hot was the mercury, and did it burn you? Big city in the East Coast. Yep. I imagine, Water Trails, that if you put out, I would guarantee you, if you put out 100 applications, you're going to get some job interviews. Poems. I do have some pets. I got a golden retriever named Ruby. What if I make it very hot? Would it keep the color? Depends on how hot we're talking. But yeah, I believe if I boiled these solutions, it would keep the colors. It looks like black hole jet, says HK. Anya, what's my favorite element from the periodic table? They love Einsteinium. Mine's hydrogen. Look at that cool pH gradient. I like hydrogen because it's pretty much the basis of all matter. It's the basis of the entire periodic table. And in stars, I'm sorry, Nobara. In stars, hydrogen nuclei fuse to become helium nuclei fuse to become carbon nuclei fuse to become larger elements like oxygen and stuff like that. Yeah, it is pretty cool on the right, isn't it? It's really cool. Let's zoom in, shall we? It's so cool because up here is pH 3, down here is pH 10, and then you have kind of like no person's land or no man's land, whatever you want to call it, down here in the middle, yeah? And the difference in acidity between this up here and this down here in terms of concentration is 10 million times more protons up here than here, and 10 million times more hydroxide ions down here than up here. It's very cool. So Ashkan was in safety gear, awesome, and dumped sulfur all over the lab. Nice. So yeah, is that what you do when there's a mercury spill? All you got to do is dump powdered sulfur on everything? Poems had some goldfish. Nobara's like an oxygen gas. If I mix it, Water Trails wants to know, is it going to be more acidic or basic? Oh, Andrew, thanks, man. I appreciate that. Seriously. Thanks for letting me know that. That's really motivational, so thank you. Okay, it looks like the line between America and Canada. Oh, it's funny. Okay, they want to know, if I mix this, is it going to be more acid or base? Let's find out, baby. Thanks, Andrew. Here we go. Let's mix that baby up. And it looks like there was more base, yeah? It looks like it. All right, sounds like my wife's home. I haven't seen her all day, so I'm going to take off. Yeah, I love it, Nobara. Thanks for hanging out, y'all. Want to go hang out with my wife? Haven't seen her all day. I appreciate hanging out with you all. You helped me, just you helped me today. Let's just put it that way, okay? I come down here to do some experiments, and it really does pick me up. It picks up my mood. So thanks for being here, and hope to see you next weekend. I usually do my experiments on the weekends, and I look forward to seeing you next time. All right, everybody? Be looking for that beauty of science everywhere, folks. You know it's there. Just check it out in the sunrises and the sunsets. It's always with us. If you just take the time to listen, to watch, check it out.